So today's topic is 5.5, conjugate root theorem. Our objective for today is I will use the conjugate root theorem to identify roots of a polynomial and write the polynomial function in standard form. Those are two main ones. The first one is use the conjugate root theorem to identify roots of a polynomial. And then our second main objective for today is to write the polynomial function in standard form. And those are two main things. And you'll show that on the exit ticket at the end of class, the quiz, and then the unit test. Those are three main ways. A little overview of today's lesson. We have a little review right here. We aren't actually going to go over. And we went over this last time, so I'm just going to leave it there just in case you need some refresher on how to simplify. Then right here, we're going to do some we/you do multiplying radicals and complex expressions. Get some practice with that when we're going to be multiplying different things, just like this. All right. Then we'll go into the definition of conjugate root theorem, and a little bit of how to use it, and then we'll get our final thing where we're actually going to answer some problems using our conjugate root theorem. Okay. We'll have two problems down there, and then we have some you do problems at the very bottom. So that will be done. All right, you'll do your exit ticket at the very end, making sure to do that since that's how the school does attendance. Make sure you always do those exit tickets. Let's go back up to the top. It says we/you do multiplying radicals and complex expressions. All right. So give you a second to get all set up. For today's lesson, probably be a good idea to have a little separate piece of paper so that you can kind of write down some stuff when you're trying to do this. Sometimes it's hard to do it within Google Docs. Right? For example, 1. So if you get confused and you want to watch a video on how to do this, there's also this extra video right here. But how we do this is our first step is we distribute the radical, which means we distribute that square root of 10 on the outside. All right, to both of these. My next step would be to combine the radicals. So that 6 and the 10 can be combined to be 60. And then my final step is to simplify the radical. All right. We went over how to simplify the radical, but I'll show you again how to do that. But again, I want to go over the steps one more time. Again, very simple. Distribute the radical. So I distribute my square root of 10 to both of these. Combine these two, and then simplify. No other steps. If I look at my annotate, when I'm simplifying this square root of 60, I like to make my factor tree. So I'll break 60 into two numbers that multiply together to be 60. The numbers I like is, say, 4 and 15, since I already chose those two numbers. And then I can break down 4 into 2 and 2. All right, I can break down 15 into 5 and 3. So now that it's broken down into its factored form, I'm going to circle the things that are alike. So my 2 and my 2 are the same, so I'll circle those. And then since these aren't the same, there's nothing matching it, I'm going to box those up. Those go together. So the 2 and the 2 become that 4 right there. And the 5 and the 5 become that 15 right there. All right. Do the last little bit of simplifying I can. The square root of 4 becomes 2. Then I'm done. All right. And again, the reason we're trying to simplify this right here is because there's a perfect square inside of here. That 4 is a perfect square. So we got to get that out. Are there any questions for this problem right here? Any questions on the process? Like, anybody have any question on why we combine the 6 and 10 instead of the 3 and 10? Or why we distributed the 10 this way instead of trying to get it the other way or something? Questions you might have? so we combine the 6 and 10 because they're both square roots. So I can combine the both right here because they both have the same thing. They are the both square roots. All right, I can't combine these two because only one of them is a square root. So I can only combine things that are matching. Right? Another way to think about this is that 3 is really 3 to the first power, and 10, the square root of 10 is actually 10 to the 1/2 power. So since they don't have the same power, I can't combine them. Right? But these two, the 6 and the 10, both actually have the power of 1/2, and so I can combine them by my power rules. Right? So these actually do combine because the fact that they actually technically have that same power, which is the square root. All right. So erase that though, it doesn't really need to be mattered. Just all we need to know is that if they're both square roots, I can combine them. If they're not, then I can't combine them. So when it asks me to simplify the radical again, this is the process. Factor it using my different things, using my factor tree, and then circle the things that are in common. So let's try a different pair of numbers. What I'm going to do is erase this. I'll choose a different number, like choose a 0 at the end. We'll choose, it's a good number. We'll choose 250 as my number. I can break 250 down into 25 times 10. And then I can break that 25 into 5 and 5. I can break that 10 into 5 and 2. And then I match any pairs together. All right, so I picked these two pairs because they're next to each other. I could have picked the other two pair, but I chose this one. And again, I only circled together pairs. So 5 and 5, and then I box together what's ever left over. The 5 and 2 are left over. And so my factored form for 250 would be the square root of 5 times 5, which is 25, times the square root of 5 times 2, which is 10. All right. Square root of 25 gives me 5. Square root of 10 can't be simplified, so we leave it as 10. Right? That's simple. Just use your factor tree, break it up, do all that good stuff. All right, let's try this out. Let's see how many people can get this. I would like you all to try this A problem right here. Following these same steps, the same process to get the simplest form. All right, I want you all to try that. I'm going to give you 2 minutes to do that. Once you get your answer, I want you to put it in the chat. If you don't finish, that's fine. We're just practicing getting used to this. All right, so 2 minutes starting now to complete A, problem A right here. Once you get your answer, put it in the chat so we can see if you're right or not. And if you're wondering how to write square root in the chat, you can write root and whatever you want. I could say root, let's say 3 is something I wanted. I just write root 3. You don't have to try and find square root or anything. You can just write root 3. All right, that's time. So let's go through this problem A right here. Let's clear off our screens. Work on this one right here. First thing I'm going to do is Control copy, insert equation, Control paste. So with this right here, what should my first step be? Everybody tell me, either by unmuting themselves or putting their answer in the chat. What should my first step be? Perfect. Someone gave me the answer, correct answer. But what would be my first step? Could I distribute? What would I get when I distribute? What would my problem look like? What will this look like when I distribute? What would my next step look like? Perfect. 4, oops, I forgot my new equation. 4 times the square root of 6 plus root 6 times root 8. All right. What's my next step? Who can tell me? I will say the longer it takes for me to get the answers, the less time you have to work on your exit ticket, the more you have to do it outside of class. All right, combine radicals, that's correct. So I have to combine my radicals. Good, I like that. Multiply the root 6 and the root 8 together. Combine those two together. So I'm going to get 4 square root 6 plus the square root of 6 times 8, which is 48. All right. Then I'm going to do some simplifying. 48 can be broken down into, so that 4 root 6 out front doesn't change. But the other part turns into a 16 times 3. Oops. Chose a fraction bar instead of the one I meant to do. 16 times 3. All right, so that's equal to, same thing, 4 root 6 stays the same, plus 4 root 3. And that's my final answer. Right, 4 root 6 plus 4 root 3. Are there any questions on that? Anybody get confused about any of these steps along the way? So I put 16 and 3 because I've already done this problem 4 different times, so it's a little bit cheaty that way. But I got 48, and I broke that down. Well, that's not going to be enough room. Took 48 and I broke it down. I can break 48 into, let's say, 4 times 12. And I can break down 12 down into 4 times 3. Break both those 4s into 2 times 2. That 4 into 2 times 2. All right. So I circle my matching one, circle my matching one. And since those both match each other as well, I can combo match them. So it's 2 times 2 times 2 times 2, which is 16. And there's a 3 left over. So that's where the 3 comes from. Right? So that's how I got 16 and 3. By doing my prime factorization, combining all the combinables, all the things that are common, and then leaving the one thing that was left over, that 3, behind. Square root of 16 became 4, then I was done. Does anybody have any questions? If you are confused, it'd be a good idea to tell me like what step you're confused at. Like, are you confused on how we went from here to here? Are you confused on how we went from here to here? Are you confused how we went from here to here? Or how we changed it here to here? Which step are you confused about? 1, 2, 3, or 4? Yeah, so with 4, I get my prime factorization, right? Let's erase this stuff right here so that it's a little bit easier to see. All right. So I have my prime factorization right here. With my prime factorization, I'm going to circle together the numbers that are in common. So my 2 and 2 are in common, and my 2 and 2 are in common. And then I have a 3 left over. All right. So the 2 and 2 and the 2 and 2, 2 times 2 is 4. 2 times 2 is 4. 4 times 4 is 16. And so that's where that 16 comes from right there. All those 2's combined. All right. And then I have that 3 left over right there. And so the square root of 16 is that 4. And the square root of 3 is left over. Right? So that's how I get that. Square root of 16 becomes 4. Square root of 3 stays the same. There's nothing I can do to 3 to make it into a perfect square. Any other questions? All right, then let's move on to the next section. These next two problems are kind of connected. All right, they're the same problem really. They're just having to do with different special things. So this one talks about square roots, while this one talks about i's. They're just slightly different between them, but the same thing happens in both of them. Because of the fact that they are perfect squares of each other, a difference of two squares, since they're both the same numbers but opposite signs, when I multiply them together, my middle term, when they multiply together, cancels out. Right? It happens up here with these two. These two right here canceling out, as well as down here with these two canceling out. Right? So both of these cancel out. And that's what we're kind of focusing on for these type of problems. And then the next thing that changes, that's nice that happens, is that the term on the right, or that square root term, will change into a whole number, right? Because the square root of 25 is 5. Because we're multiplying it together twice, it'll always turn into a nice number. Same thing down here with the negative 4i squared. Because I squared equals negative 1, I can change that into a negative 1 and get a whole number. And so this is part of our conjugate root theorem, in that these are called conjugate roots, right? They are opposites of each other in the fact that when I multiply them together, the i's go away, right? And when I multiply these two together, I get a whole number, right? And so we can follow that same path by foiling it out, doing all the work, getting this final answer. But I'm not going to go over it too much, because I feel like it'll just be a waste of everybody's time to do that. But the real quick definition is I distribute, like we know how to do, either using our FOIL, our table method, or difference of squares. Once I FOIL it, I combine my things, like the 4 and the 5 become a 4 root 5, the 5 and the 5 become a square root of 25, and I do some simplifying. These two cancel, this becomes a 5, simplify. Same thing down here. FOIL it all out. Simplify the middle 2 by getting rid of it. Change that I squared into a -1. And then do a little bit more simplifying and then you're done. All right? That's simple. I would like everybody to try B and C. Before we do, are there any questions on the process? Right. I will say one last thing before we start, that it's a good idea, a good check to see if your answer ends up being a whole number, like 5 or 20 or 30 or something like that, then you are good. If your answer ends up having square roots in it or i's in it, then your answer is not done. All right. Now I want everybody to try it. I'm going to give 4 minutes to try B and C. Once you're done with B and C, I want you to put that in the chat, right? So we can see how you're doing. So 4 minutes starting now to complete those. Try it out, see what you can do, and then we'll go over them together. All right. So let's go over B first. Okay, I'm going to copy paste this one over. Copy, Control paste. What's the first step I do in this problem? Tell me. Not just what I do, but what I get. And I think everybody can read up here that we distribute. What should it look like? And it might be easier to unmute yourself and tell me. Perfect. Ooh, you're doing the one down here. That's perfect for down here. Doing B first, though. Perfect. I'll put that on the board. Control copy. Equation. Control paste. Let's rechange those all the square roots. Square root of 3. Control copy. Copy pasting so that you can change things really easy. Paste root of 9. All right, I foiled all these out, and now I just got to do some simplifying. The nice thing about these is that these two cancel out right away when I simplify. And so I end up with a very nice number. Equation. It's 49 minus the square root of 9, which is equal to 49 minus 3, which is 46. So my final answer is 46 for this one. All right. Are there any questions on this problem before we move on? Yeah, I can go over the distributing part. Put my annotate up. Again, when I distribute, there's 2 different methods. You can use your FOIL method, right? Distributing these, distributing these, distributing these. Do all that stuff. You could use your table method, making a box like a tic-tac-toe board. Your 7 and negative square root 3 go in these ones. Your 7 and positive square root 3 go in these 2. And you just multiply. Right? I'll do this version, so it's a little bit easier to see. 7 times 7 gives me 49. 7 times the square root of 3 gives me 7 root 3. Negative 7 root 3. And then root gives me a root combined, which is 9, with a negative out front. Right? That's that's what I call my table method. To do that, put them all written out. 49 plus 7 root 3 minus 7 root 3 minus the square root of 9, and then cancel these 2 out. Cancel out. Simplify a little bit more. Get the right answer. Are there any questions on that? Any more questions? If that makes sense. Or do you want me to show the other FOIL method? Anything like that. All right. Let's move on to the one below it. That's my spotlight. Someone actually already gave me in the chat the correct next step. I'm going to scroll down. I'm going to clear my screen and scroll down so we can actually see it. I'll leave that up there so you can still see. But when I FOIL this out, I end up with something that looks kind of like this. Except the squared term didn't come through. All right. I end up with this. My next step would be to cancel out these middle terms right here. So I get 36 minus 9 I squared. What's my next step? You can tell me what my next step should be in this problem. That's a great explanation for it. So someone said if I equals -1, then wouldn't I squared equal 1? That's slightly off. So I does not equal -1. I equals the square root of -1. All right, don't forget that square root part. So when I square it like this, these two cancel out. All right, the square and the square cancel out. And so I get I squared equals -1. That's where that -1 comes from. All right, because of the fact that these two cancel. But I still have the square root of -1. That's what I equals. All right, let's plug that back in. Some other students said. New equation, 36 minus 9 times -1, which is equal to 36 plus 9 now, which is 45. Are there any questions on that problem before we move on? All right. Any last second questions before we move on? Anything at all? All right, let's move on to our definition. I'm going to say the full definition, and then I'm going to cut out some parts and kind of talk about it. So first thing, my definition is if P of X is a polynomial with rational coefficients, then the irrational roots of P of X equals 0. Then the irrational roots of P of X equals 0 that have the form A plus the square root of B occur in conjugate pairs. Meaning, if A plus the square root of B is a root, then A minus square root of B is also a root. Similarly, the imaginary roots of P of X equals 0 that have the form A plus BI occur in conjugate pairs, meaning if A plus BI is a root, then A minus BI is also a root. That's our fancy way, and a really math way of saying that if I have something that looks like this, I didn't actually mean to do that. If I had a problem and it said one of the roots, if I had a root of, let's say, 2 plus the square root of 3. Now let's say that that is one of my roots. They come in pairs. So I can take the opposite of it, put a minus sign in between, and it will also be a root. So if 2 plus the square root of 3 is a root, then 2 minus the square root of 3 is also a root. Now, the reason that's true is because of what we did right above, right? Because of the fact when I multiply these two together, I get a whole number, I get a rational number. That's the only reason, right? So if I wanted something to have rational roots, rational coefficients, and I didn't have their complex conjugate, I would have square roots in my problem. I would have square roots in my answer. And so that wouldn't really work out in the end. And so what we have to have is our conjugate pair, because when we multiply these together, they cancel themselves out and we end up with a nice whole number. All right. And so that's kind of what it's saying, is they have to be a pair for it to be rational, right? For me to have rational coefficients. Remember, the coefficients are the numbers out front of my x's. So if I had something like x squared, I usually have something like ax squared plus bx plus c. My coefficients are a, b, and c. And what it's saying is that these are just like fractions or whole numbers. They're not square roots. They're not i's or anything like that. All right. Same thing down here is that if, let's say that we had something like, make it easy, 4 minus 7i is a root, its conjugate pair also has to be a root. So 4 minus 7i is a root. Then 4 plus 7i is also a root. All right. It's that simple. That's all it means. If it's something like this, if it says it's a rational coefficient, and we have something that's irrational, something with a square root, then its opposite also has to be true. It's conjugate pair. All right. Are there any questions about this definition? Anybody at all? All right, then let's test it out. Let's see how many people can tell me what my conjugate root will be. If I had a root that looked like this, if I had two roots, one of the roots was, let's say, the square root of 7. The other one was 6 minus 2i. Who can tell me my extra roots in this case? Who can tell me what my extra roots should be? These were my original ones. What should my extra roots be? Let's do this. If we have what, 25 students in the chat right now, if we can get half that number, so we'll go 13, we'll round up. If 13 people can tell me this right answer, then I will give everybody an extra credit point. All right. If they can't, then they can't. So who can tell me what the two extra roots will be based on what we did up here? 2 plus root 3 turned into 2 minus root 3. 4 minus 7i turned into 4 plus 7i. We currently have one correct answer. We need 12 more. All right. I will be a stickler for this. It needs to be correct. That's 2 correct answers. 2 out of the 13 we need. So we need 9 more students that were paying attention and are able to do this. Let's put a little timer on this so that we, can move on a little bit. So that right there is a 2, by the way. Someone thought it might be something else. That's a 2. Put a little timer on it. You have 2 minutes to get me the answers. All right, so currently I have 3 now correct answers. One person is giving me a half correct answer. I'll put up a little half finger. All right. Another correct, oh no, not quite. Someone gave me the exact same numbers. That's not quite right. You have a minute and a half to get me those 9 answers. Currently, we're at 3.5. I have another half point, so I'll put that up. Ooh, someone gave me another almost right answer. Someone gave me close to the right answers again, but not quite right answers. Look at what we did right here and try and tell me what these would be. Right? You have 1 minute left to do this. We need, what, 9 more people to do it? So you guys don't want that extra credit point. It's another correct answer. That's 5. We've got 30 seconds left. Ooh, a very close to right answer, not quite. It's not looking good. We got 15 seconds left. And that is time. All right, we'll have another opportunity a second to try this again. The answer that someone gave me that was correct was the negative square root 7 and then 6 plus 2i. It's that simple. All I do is I change my sign. Change the sign. Change the sign. All right? It was a positive, now it's a negative. It was a negative, now it's a positive. Right? Now that we know that we all don't seem to know what we're doing, does anybody have any questions on this? All right, then we're going to move on. Try one more problem. Try one more chance for extra credit. And we're going to move on. So if I was looking at a problem like this, example 4, I have 5 over 2 and negative 2i. They're both roots of p of x. I want one additional root. Because of the fact that this is a complex root, an imaginary root, I know that it has to come in a conjugate pair. All right, so whenever I see an I or a square root, I will have a conjugate pair. On the other hand, so my roots for this one so far are 5 halves and negative 2i. My conjugate root theorem only tells me that my extra root will be of the I form. All right, i's and square roots are the only ones that work. So I take the opposite of my negative 2i and get a positive 2i. All right, so this would be my other root. Only works with i's and square roots. Let's write that. Only works with i's, imaginary numbers, and roots. All right. Are there any questions on example 4 before we do problem D? Anybody confused on why any of this happens? Remember, this one did not work because of the fact that it is not an I and it's not a square root. All right, let's try it then. Let's see if everybody can do D. If I can get at least same thing, 13 people to tell me the right answer, then we'll be good. We'll move on. We'll get that extra credit point. What are my rational roots? What are my extra roots if I had my roots as square root of 2 and 1 plus I. I already have 2 correct answers, 2 of the 13 we need. That's 3 correct answers, 3 for 3 so far. Four correct answers, 5 correct answers, 6 correct answers. Remember, we need to get to 13 right now. We're currently at 6. We need to get 7 more people. Put on the timer for 2 minutes now. You have 2 minutes to complete this. We currently have 6 people. We need 13. It's not looking good. It looks like everybody's kind of giving up. Remember, we're doing D right here. You're going to get an extra credit point if you can do this. If you can't, you're letting your team down right now. Not quite. Remember, look at what we did right here to get to here as my extra root. Look what we go here, try and get your extra roots from there. Right, we already have these 2 roots. Give me some other ones. Give me the other ones. We have about a minute left to get these answers. All right, it's not looking good. 50 seconds left. It's another correct answer. So we're up to 7 now. We just need 6 more. We have 40 seconds left. So we just need 6 more people to answer. It's not looking good. Some people are bailing, trying to get the numbers down. That's not how it works. It's not looking good. You got 20 seconds left if you want to try and give an answer. Even giving an answer is better than not giving an answer. At least you're trying. That sucks. All right. That's time. Unfortunately, we didn't get one today with the square roots and everything and our answer. Maybe you guys should all make sure you're paying attention more when I'm asking things. You could have gotten extra credit just now. Too bad. Especially with this early time right here. 2 points of extra credit that you guys just missed is pretty much half a homework assignment. So you could have gotten those points back because some of you could have had a 100% in the class after that. Too bad. All right, so we're going to move on then. The 2 numbers should have been the negative square root 2 and then 1 minus I. All right, those are my 2 square roots. Opposite sign, opposite sign. That's all it is. Take my opposite sign. And again, this only works if it is an I or a square root. Right? When I look at the problems down here, for example, 5, I have this negative 4 and this 3i as my roots. The negative 4 won't have one because it does not have an I in it or a square root in it. 3i does have an I in it. So since it's imaginary, I will have an extra root of negative 3i. Nothing. All right. This one does have one. I plug that in for my equation just like we did this morning for our warm-up. Simplify and we get our answer. I'm not going to go through all of those steps because it will take a little while and we are running out of time. After looking over this, does anybody have any questions on this? Remember that this part right here, the simplifying part, we've already done before last class. That's just foiling out. Pretty much everybody was able to do that during the warm-up. That's just some FOIL. Does anybody more have a question on how we got this right here, or how we set it up like this? That's more of what I want to focus on. Any questions on that? So when I rewrite my equation right here, I take my roots that I already had, the -4 and the 3i. And I took my new root that I found, which is the -3i right here. And I do my x minus trick. So it's x minus my number times x minus my number times x minus my number. My three numbers in this case were a -4, 3i, and -3i. All right, when I plug those three in, and negative gives me a positive, so I get x plus 4 right there. Negative positive gives me a negative, so I get x minus 3i. And then negative again gives me that positive of x plus 3i. Right? And then that's my answer. That's how I set that up. Plugging in all three of my numbers, doing a little bit of simplifying. Don't forget the equals 0 part at the backside. And then I solve and I'm done. Any other questions? Or a better thing is also, does that answer your question? Is that how you, does that make sense to you, or do you need me to explain it some more? Yeah, I can explain it some more. So again, there's another way kind of to think about this. If you don't like this like plug-in number thing, you can set each one equal to x. All right. So my first one will be x equals -4, because this is all it really means, is that to be a root of something means that x equals it in my equation. All right, my next one is x equals 3i, and x equals -3i. And then to solve, I just move everything over. So to get rid of this one, I'm going to move it over here. So I'm going to add 4 to both sides. Add 4. X plus 4 equals 0. Subtract 3i. X minus 3i equals 0. And then add it. X plus 3i equals 0. All right, so now that I have all three, I put them together. And that's another way you can do it. All right. But again, I got my roots for doing this. And then I just take them backwards. I can think about it this way if you want, or you can think about it as just plugging in however many you have. All right, either way works. But really all I'm saying is that whatever number I plug in right here, like the -4, will make this 0. If I plug in 3i right here, it'll make this pair, this little parentheses, 0. If I plug in a -3i right here, if I plug that in there, I'll end up with 0. Right? That's all a root really means. Then we just do some foiling, just like we did earlier today. Simplify, 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 until it all goes away. Foil some more, and then we'll end up with our nice numbers. Right? Now, a good check to make sure you're doing this right is to make sure you have no i's in your final answer, or no square roots in your final answer. All right? Are there any questions about this other than what we've already said? Or any repeats does anybody need? I'm gonna clear it off in about 10 more seconds. So make sure if you haven't already done it, write it down. We're gonna move on to one last thing. So we kind of ran out of time to do the you do section and still be able to do our exit ticket. So I'm going to give you the work for the you do section. But if you want to, you can copy down. Control paste. Backspace. All right. Next one. Control copy. Paste. And the last one's a little bit longer. Copy quite a bit longer. Control paste. I know, crazy. Let's try and see if I can fit some more stuff on the screen. How can I do this? You know what I can do? Do this cheater method. Forgetting to click enter. There we go. Now let's see how much we can get on this same page. Insert. There we go. Now we got it all on the same page. Those are your 3 answers to the 3 different problems. What I would like you to do is check them out, see what you need help with or anything, and then you can start on your exit ticket whenever you're done with your questions.